Diving equipment. In this module you will learn about the equipment we use that allows us to take the air we need under the water, examine the instruments that make it possible for us to use this air supply, and see how these instruments are used. Cylinders and cylinder valves. One more step and you will be in the water, in a world that is both fascinating and mysterious at the same time. The doors to this new and exciting world are about to open. But when did modern diving begin? Diving, as we know it today, began only after the Second World War, when some pioneers produced the first equipment for recreational divers. In the beginning, this equipment was heavy, cumbersome and delicate, but with time it has become simpler, more comfortable and more reliable. Air is compressed into a metal container, the cylinder, which we take with us and use on the dive. A compressor is used to compress the air we use to fill our cylinders. In practice, this is a machine that pushes air into the cylinder. A compressor is used to compress the air we use to fill our cylinders. In practice, this is a machine that pushes air into the cylinder. Increasing the pressure reduces the volume of air, so a large quantity of gas can be stored in a relatively small container. To work out the volume of air available, with European cylinders you can just multiply the internal volume of the container, referred to as the capacity, by the pressure to which the gas has been compressed. For example, if we have a 10-litre capacity cylinder containing air compressed to 200 atmosphere, the volume of air available, once it has been re-expanded to atmospheric pressure, is 2,000 litres. To indicate that the litres are calculated at normal atmospheric pressure, we use the term normal litres. Cylinders are made of various materials: steel, aluminium and composite materials. They come in different capacities. Your instructor will tell you which are the most common in your country. All cylinders have important markings, such as the maximum working pressure and, in Europe, the test pressure. The maximum working pressure is the lower figure. Other information may also be marked on the cylinder, such as the capacity, the weight, the gas it may contain, etc. An important marking is the test date. This is an obligatory periodic test that ensures that the cylinder is safe to use. Regulations regarding cylinder markings and tests vary from country to country, so make sure you know the regulations in your country. Cylinders are fitted with cylinder valves, to which a device called a regulator is attached. This reduces the pressure of the air to ambient pressure. A rubber ring, referred to as an O-ring, creates the seal between the cylinder valve and the cylinder. The valves may be single or twin. A twin valve means that it is possible to attach two separate regulators to the same cylinder. The seal between the cylinder valve and the regulator is also made by an O-ring. Cylinders should never be left standing because they can easily fall over and injure someone or be damaged by the fall. As soon as possible, lay the cylinder on its side and make sure that it doesn't move or roll about accidentally. The regulator. Cylinders allow us to take a supply of air with us under the water, but how can we use this air efficiently? To breathe underwater, we need a demand regulator that enables us to breathe air from the cylinder at ambient pressure when we need it by simply breathing in. Modern regulators are two-stage or single hose, meaning that they are made up of two distinct parts, known as stages, which are connected by a single hose. Air is supplied at ambient pressure, whatever the depth or the pressure in the cylinder, as long as there is still some air in the cylinder. The first stage reduces the pressure in the cylinder to an intermediate level known as hose pressure, which is lower than that inside the cylinder but higher than the ambient pressure. The first stage is attached to the cylinder valve. Depending on the model, the connection may be of the yoke type or INT fitting, which is a quick attachment system consisting of a clamp and a clamp screw, or the DIN fitting, in which the first stage is screwed directly into the cylinder valve. The second stage is the part you put in your mouth and which reduces the hose pressure to ambient pressure. Thanks to the regulator, breathing underwater requires the same effort as breathing normally in air. The second stage is composed of the body, which contains all the mechanical parts, a mouthpiece of soft rubber, the part we put in our mouths, an exhaust tee that directs the bubbles of air we exhale to the sides, and a purge button which, when pressed, supplies air. A regulator is a delicate mechanism. It must be rinsed after each dive when it is still connected to the cylinder, or after it has been disconnected and the air inlet has been closed tightly with the protection cap. When rinsing the regulator, you must never press the purge button, otherwise water will get inside. Even if it seems to be working well, a regulator must undergo an annual inspection by a specialized technician who will substitute the parts that can get worn. This is the only way to make sure that your regulator is always reliable. Buoyancy compensators. Thanks to your equipment, you will be able to attain a condition of neutral buoyancy underwater in any situation and stay suspended in midwater without effort. The piece of equipment that enables you to do this is the buoyancy compensator, or BC, which can increase the diver's volume to counteract the effects of the weights and compensate for the wetsuit becoming thinner at depth. The buoyancy compensator consists of an inflatable bladder, some straps or a harness that connect it to the body, and an attachment system for the cylinder. The buckles of the straps attaching it to the body are of the rapid release type and can be adjusted easily, making it easy to put on. The cylinder is attached to the BC with lever-type buckles that guarantee that the cylinder stays firmly in place. However, it is always best to check that the cylinder is fixed tightly. The BC has an inflator-deflator device that is connected by a fast-release connection and a hose to the first stage of the regulator. There are various types of inflator-deflator devices, but they all have an inflator and a deflator button. You must be possible to operate this device with just one hand. On some models, the inflator-deflator mechanism is at the end of a corrugated hose. On others, it is on the side of the BC, where it can easily be reached. When you use an inflator-deflator device that is fitted at the end of a corrugated hose, you must remember that the end of the hose must be held up high when you want to deflate the BC, otherwise it would be like trying to fill a bottle while holding it upside down. All buoyancy compensators have a system that can be used to inflate the BC orally. Finally, BCs must also be fitted with overpressure relief valves that open automatically if the pressure inside the BC is too great. This prevents the BC bladder tearing. These valves can often be operated manually and therefore have the additional function of also being a rapid relief or dump valve. The important characteristics of a buoyancy compensator are that the bladder is sufficiently large, at least 12 to 15 litres, 0.4 to 0.5 cubic feet, and that it is suitable to your body size and shape. When you are wearing a BC, it shouldn't move around or rise upward. Also, it shouldn't be too tight around the chest when the bladder is completely inflated. The BC should be rinsed after every dive and left to dry in the shade, like all the other equipment we have examined up to now. It is also important to drain out any salt water that may have gotten inside the bladder and then rinse the inside well with fresh water. Buoyancy variations. buoyancy compensators enable you to adjust your buoyancy during the dive. The BC should be well inflated on the surface so that your head is held as high as possible out of the water. To go under the water, you have to deflate the BC and exhale as much air as possible from your lungs. The amount of weight worn must be sufficient to help you descend slowly under the water. The BC compensates for the variation in buoyancy caused by the change in pressure. In fact, as you begin descending, the volumes of the wetsuit and the air in the BC decrease, causing you to become negatively buoyant. To counteract this, just inflate the buoyancy compensator a little at a time. This phenomenon is reversed as you ascend, so in this case you have to deflate the BC gradually as you come up to the surface so that the rate of ascent is always under control. Do not inflate the BC to ascend because this will cause you to ascend too quickly, a potentially dangerous situation that is sometimes referred to as going Polaris. With practice and experience, you will be able to move freely under the water and enjoy the same sensations as flying through the air. In the next module, you will learn the correct way to breathe underwater. Find out how to calculate how long your remaining air supply will last, and learn what to do if you find yourself in an out-of-air situation. Until the next time.